In our CRUD overview lesson, we briefly touched on a few different ways we can query data from our database. Now, in our overview lesson, we learned that there's two different ways we can access the query builder. We can access it from our database module by calling database.from and then providing the table name that we want to access. And then from there, we're given the chainable of the query builder. Alternatively, we can also access it via our model. So in this case, we're using our project model. And from our model, we can call the query method, and then from there, we return a chainable of our query builder. In most cases, both of these instances are the same, so we're going to be just picking one and moving ahead with that one for this lesson. Just note that for most of these instances, you'll be able to use these methods interchangeably between these two usages. There will be a couple of use cases where we specifically need to use the model query builder because these methods will be specific to that instance. And for that, we will switch from the database module over to our model query builder. Okay, so to start out with, we're going to be focusing a lot here on where statements because where statements are pivotal to filtering down the data that we query from our database. And beyond that, there's also actually a lot of variants that we could use with the where statement. So for this particular where statement here, there's actually three different variations that we can use. So the first argument here is the column name that we want to perform the where statement on. And then the second argument is the value that we want to check against in the database for this particular column. Now this usage here with the two argument approach is actually doing an equality check. So this value here must match the value provided within this column. So our IDs must exactly match. If we're using something where that's not really going to be achievable, maybe with like a created at column, we have a third argument that we can provide in between these two, which is our operator type. And within here, we can provide less than or equal to, greater than or equal to, or just greater than. And we'll pause here for a second and we'll perform some form of a check here. So let's do created at is greater than, maybe we'll use Luxon's date time here to grab the current date time, and then we'll convert this to a SQL string, and we'll perform that check with this where statement. So here we're checking for projects where the created at is greater than the current date time. Doesn't make a whole lot of sense, but you get the gist of why this would exist. Now, let's say we're using something where maybe we can't do less than, or maybe we're using something like a string, like we're checking for our project's name. Greater than, less than doesn't quite make sense. So we have an alternative approach here that's useful for strings called the like operator. And essentially what this is going to do is it's going to allow us to check for a particular string. So using this approach, we can check for a string that starts with, ends with, or has a particular value somewhere in between a string value. So if we get rid of our date time here and we provide just a string, so let's say we are searching for a project where maybe it starts with the string my example. Well, we actually have a wildcard here that we can provide with the like operator, which is just this % here. And what this will do is essentially say, we don't care what is after, we only want to know that it starts with my example. So here, if we have a project with the name my example project, that would show up with this query because we're searching for all projects where the name starts with my example. Now, if we add a % to the start of this string, now we're saying something slightly different. Now we're saying we want all projects where the name contains my example. So now instead of doing a starts with check, we're now doing a contains check. And this would be the equivalent in JavaScript world of doing something like an includes method call on a string. And then lastly here, if we get rid of the last %, what this is doing is it's saying we don't care what the string starts with, we just want to know that it ends with my example. So here we're saying we want to query all projects where the name ends with my example. So if this is project, my example, that would show up with this result here as well. Okay, so that's the first argument type that we have available to us with this where statement. The second one, if we get rid of our arguments here, is actually just providing an object. And so if we wanted to perform something similar here, we could do a search for a name where the value is my example project. So now this is checking for all projects where the name is equal to my example project. Now, one reason why this approach is nice is because you don't have to chain an additional where statement off to do an additional where. Instead, you could extend your object here. So we could do maybe where status ID is equal to 1. So now we're doing two where statements in this one where call. As opposed to the other approach here, if we go back to add an additional where statement here, we would need to chain off another where call. Okay, so now the last argument type that we have available to us with the where statement is actually a callback function. So here, if we get rid of our arguments again, so what this callback function will actually provide us is essentially a wrapped where statement, right? So it's you could think of using a callback as wrapping our where statement in parentheses. So here, this is going to provide us our query instance, and we can do whatever we want to within here. So we can do query where status ID is equal to 1. We could do where name is equal to. We could chain this off as far as we need to, and it would be perfectly valid. Now, in essence, what this is going to do is if we do a where statement up here. Let's say maybe where name is equal to my example project. And let's actually break this down a little bit so it's easier to see. And let's get rid of the first or fail. So in essence, if we were to write this in SQL, what this is going to do is it's going to select star from projects where name is equal to my example project, and then it's going to wrap our callback query within parentheses here. So now we can do and status ID is equal to 1. And what this provides us the ability to do is actually do and or statements within our where clause. So in this case, it doesn't make too much sense to use this callback approach for this particular usage. But let's say we want all projects where the status ID is either 1 or 2 and the name is my example project. So here, to extend this off to say that, we can actually do an or where status ID is equal to 2. And so now what this would look like is we would have an or status ID is equal to 2, and I'm not formatting this very well, but there we go. So now we're searching for all projects where the name is equal to my example project and the status ID is either 1 or 2. Now, it wouldn't make sense in this particular usage, but we could also do and where if we wanted to. And essentially here, the where statement acts as syntactical sugar for and where if we chain them off of one another. So these two statements here would be saying the exact same thing, are where and where. Alternatively, here we can do the inverse. So we could search for all projects where the name is equal to my example project and the status ID is not 1 or 2. So to do that, we have an alternative where statement method here called where not. And what this essentially says is we want the status ID where it is not equal to the value that we provide, in this case 1. And then here we would also want to do another where not as well to state that it also cannot be 2. Alternatively, here we also have available to us and where not, if you prefer that as a more readable approach. And then just to round out all of our coverages here, we also have or where not as well. Okay, let's go ahead and simplify this query back down to just a simple where statement here. Let's say that we have an array of IDs. So const IDs equals 1, 2, and 3. And I'm also going to get rid of this little query down here so it's out of the way. So let's say that we want to find all projects in our database that match the IDs within this array. So to do this, we can change our column search here to an ID, and we can change our argument to this array of IDs. However, the where statement isn't going to handle this all by itself. Instead, we need to use the alternative wherein method. And what this will do is it will take the column that we provide, in this case an ID, and it will search for a value in any of our array values. So 1, 2, or 3. So it's going to return back to us all projects where the ID is either 1, 2, or 3. And then just like with our where not, we also have and wherein, or wherein, or where not in, and where not in, and then just where not in as well. And what where not in is doing is it's searching for all projects where the ID is not in this ID array. So it's going to return all projects where the ID is not 1, 2, or 3. Okay, next up we also have a where null check. So let's change this to something that is nullable within our database here, so maybe description. And then we want to query for all values where the description is null. Now, since we're specifically checking for a null value here, we don't need to provide a second value-based argument, and we could just provide the column name that we want to check against. So here we're searching for all projects where the description is null. Again, just like the other two instances, we also have and where null, or where null, and then lastly, where not null. So now we're checking for all projects where the description is not null, where it has some form of a value. And then again, this also has and where not null and or where not null available as well. Okay, and then for these last three here, I'm going to go ahead and jump over to Connects.js's documentation because they have better examples that we can take a look at. So keep in mind within Connects.js here, if we replace this connects and then the table name with just database from, we have essentially the same thing. Not quite the same thing, but roundabout. So first here we could call where exists and provide it a callback function, and then provide it a subquery within this callback function. And what this will allow us to do is check whether or not another relationship or another record in another table or the same table exists within our database for this particular query. So here we're going to get all users that actually have an account record within the database. And we can do the inverse using where not exists as well. We can check for all users where they do not have an account record within our database. The next one is where between. So we could search for all user votes where it's between 1 and 100. And then we could do the inverse where not between. So where all users have votes that are not between 1 and 100. So it would need to be either less than 1 or greater than 100. And then lastly here, we also have a where raw statement here. So we can provide a raw-ish where statement here with a question mark in place of the actual value that we want to search for. And then we provide the actual value as an array in our second argument. And the reason why we want to use this approach instead of just plopping the value directly in the string is because we want to protect our database against SQL injection. And this where statement will help us out with that by ensuring that the values that we provide aren't anything malicious. Okay, so that has us covered for our where statements. If you want to see examples for these, you can check out the lesson for this video. We're going to go ahead and move on to other common use cases that you would need to chain off of your where statements to alter how your data is being returned back to you. So let's go ahead and just get ourselves back to a basic where statement here. So where status ID is equal to 1. And first and foremost here, let's take a look at ordering. So let's say that we want to get all projects where the status ID is 1, and we want to have them returned back to us in alphabetical order. So to do this, we can use a method called order by, and we can provide it the column that we want to perform this sort on. In this case, we'd probably want to do it on the name of the project. So by default here, this will actually use ascending for the direction, which is A to Z, 0 to 100, 1960 to today. If you're thinking in terms of various values that you could perform this particular sort on. If we do not want ascending sort here, we could provide a second argument with descending. And descending is Z to A, 100 to 0, now to 1960. So if you want ascending, you could leave this off entirely, or you could manually provide ascending as well. And this will order our results by the column that we provide. In this case, we're providing our name whenever it executes the SQL. So in this case, we're going to get back all our projects with a status ID is 1, ordered alphabetically by name. Okay, so let's say that we want the last 3 projects with a status ID of 1 within our database. So we can make use of our where statement, our ordering, and then we can make use of another method here called limit to limit the number of results that we get back with our query. So here we will want to provide 3 because we just want the first 3 records that match our criteria. Second, we want to order by our created date since we want the last 3 records that were created within our database. So here, created at, and then since we want this to be the last 3 records and not the first 3 records, we want to order descending, since descending would be now to 1960, whereas ascending would be 1960 to now. Alternatively here, when we briefly covered this in the overview lesson, if we just want 1 record back, we could call limit and provide a 1, or we could also call the first method, and this will just return back the first result that matches our criteria. Limit 1 would still return us back an array, whereas first would return us back an object. So a slight difference there. And then you also have first or fail if you want the execution to error out as a 404 if a record cannot be found. Okay, so next up, let's talk about data aggregation. So let's get ourselves back to a where statement here. And let's say that we want the total number of projects within our database that have a status ID of 1. To do this, we can use a method called count. And then since we're just searching the columns that are within the database here, we provide a wildcard of star. And what this will do is it will count all records that match our criteria here where the status ID is 1, and it will return that count back to us. So this would look something kind of like this. So it would be an array with an object, and then it would depend on your database driver exactly what this is called. But for MySQL, I think it's something like count and then exactly what you provide within the count argument here. And then it would be the actual count that it finds. So this is kind of what you would get back by default with this particular query. So to combat this, we can actually give the record that this count would save into a particular name. So to do this, we can do star as, and then we just provide the name that we want it to be. So in this case, maybe total. So now the structure here is going to be the same. The only thing that's going to be different is this particular name right here. Instead of being count, parentheses, star, it's going to be total. And then the total number of records that it found matching our criteria. This as name structure is actually applicable to all of the aggregation methods that we're about to talk about. So here we have count. Okay, so next let's go ahead and move on to min and max. So to do this, let's actually use one of our intermediary tables here. So let's use project task, and that's one of the benefits that the database module allows us to do. So we don't have a model for our project task. We could use the relationship to query from this, but it might be a little bit simpler in this case to just read directly using our database module from our project task table. So we can do a query on our project task table, and let's get rid of our where statement here because we won't particularly care about any particular values in this case. And let's change our count to a min. Now, instead of doing star here, we actually do need to provide a column that we want to get the minimum value of for. And within our project task table, we have a sort order. So not exactly an ideal example, but it is one of the few numbers that we have within our database schema here to work with. So what we would be getting with this particular query is the minimum sort order within our project task table. And instead of saving this as total, we would probably want min sort or min underscore sort or something of that nature. And then this total name here would match that naming that we gave it. Alternatively here, instead of min, we could also call max to get the maximum sort order that's found within our project task table. And then we could give that a name as well as like max sort, and then that would adjust here as well too. Okay, so next up we also have a sum method available to us. And what this will do is it will sum up all values for the particular column that we provide. Doesn't make sense in this use case. We wouldn't necessarily ever want to sum up our sort order, but I just want to show that you can use sum in this fashion to get the sum of all values for a particular column in your database. And then here we could give it a name as well, and then that name would be returned back to us within our value. And then lastly here we also have an average. So again, you wouldn't want to necessarily call an average on your sort order because the data is just not useful. But I want to show that you can do it if you do have a particular column that it would be useful for. So this is going to get the average of all values within our database for the column that we provide. In this case, our sort order. And then again, you can provide a name for it as well. Okay, and then we also covered this briefly within our overview lesson, but we also have available to us a select method, which will allow us to define exactly which columns we want back with our query. By default, this is selecting all columns here, which would just be a string value of a star. Alternatively, here we could provide a single column by just providing a string of that column, or we could provide an array of columns if we need multiple columns back. So if we had a select and we were querying for values for that select, maybe we would just want the ID and the name, the ID so that we could use it to bind that data to whatever we're selecting for, and then the name so that we could show it to the user. This is how we could go about that approach. And then we don't have these two records on our project task, but we could call this on our projects table. Okay, so let's say that we are querying from our project user table and we need all admins. So that where role ID is, and we don't have an enum set up for this, but let's just assume that the admin value is 1. So here we'd be querying within our project user table, getting all relationships where the user is an admin, in this case, assuming admin is 1. Okay, so let's say for this query, we only want back one instance of a user. So since users can belong to many projects, and they could also be an admin in many projects, we only want one user back for our query per user. So we don't want our query to return back user 1, project 1, role ID 1, user 1, project 2, role ID 1. We just want that first instance of our user 1 returned back where they are an admin. To do this, we could call the distinct method. And then what we would do is provide this an array of the columns that we want to be particularly distinct. So here we could do user ID to get back just the distinct records for our user ID. So in this case, we would just get back user ID 1, role ID 1, project ID 1, instead of user ID 1, role ID 1, project ID 2. We would just get back the first instance that I found with our user ID 1. If you need to take two columns into consideration with your distinct call here, you could also provide a second column here as well. So here we would be doing a search for our user ID and role ID where both of those values combined together would need to be distinct. Okay, but what if we need to group multiple rows of the same value together? We don't really have a good use case for this in our schema, but we can stretch our reach a little bit to get an example. So let's say we want a query to determine all the roles a user has for any project, but we don't want any more than one role back for that particular user. We can alter this query here slightly. So to start with here, we are querying for a particular user. So we would have user ID where the value is 1, or whatever value we're searching for this particular user. We would want to select just the columns that we care about here. So we would want just the user ID and the role ID. And then instead of calling distinct, we could call group by to group those instances together. So to paint this out in a better picture here, let's say we have our user ID all ones. We have a role where this user is a admin in 2 projects. And then we have a third project where they are the second role, which let's say it's a moderator. What group by here would do is it would group these 2 records together, since in this case the user ID and the role ID are identical. So in essence, we would get back just these 2 records instead of all 3. So that's how group by can be used to group multiple records with the same values together into one record. Okay, so lastly here, let's cover conditionals. So let's say that we have a filter, but we're not sure whether or not this filter is actually going to have a value. So we're not sure whether we should apply it to our where statement because we don't want to search on empty. So let's set a variable here to serve as our filter. And let's say that we're doing a status filter, right? We want to allow the user to select which status they want to query for, and then that value would be within here. So we'll just set this to 1 manually for right now. So the way that we could determine whether or not our status filter has a value and then apply it if it does or ignore it if it does not is by using a method called if. Now, in order to do this, we cannot use the database module here. We actually need to use our model because this is a model specific method that Adonis provides. So here, let's do project query. And then to conditionally apply this, there's a method called if. And then I'm going to hit exit on the autocomplete because for some reason mine wants to keep doing find index instead of if. But if is a valid method here. We can do if our particular condition, so status filter, if status filter has a value, and then the second argument here is actually going to be a callback function with our query inside of it. So we can use this to conditionally apply whether or not we should query off of the status ID filter. So here we do query where status ID is equal to our status filter. So if we have a status filter, this will get tacked on to our underlying SQL query. If status ID does not have a value, so if this is null, this if statement will skip over our query callback and leave it off of our SQL statement. So this is a really handy way to conditionally apply filters and other forms of where statements and conditionals onto our SQL statements. So I almost forgot here, but I also want to touch on the fact that we also have a paginate method available to us off of our model query builder. So the first argument that we would provide this here is the page index that we are currently on. So, if you're on your first page, then it would be 1. If you're on your second, then it would be 2, third, it would be 3, and so on and so forth. And then the second argument is the number of records that you want to be on each page. So in this case, they have the limit to 10, so you get 10 records per page. So if you're on page 1, you're going to start from record 1 and then go to record 10. If you're on page 2, you're going to start at record 11 and go to record 20, and so on and so forth, depending on the argument values that you provide here. And then what this provides back to you is a pagination object here. So we have the rows that we have within our database here. So these would be all of the records that we get back from our particular query. And then we have the total number as a string that we have within our database matching this query. So this is the total number of records that we have across all pages, the number that we have per page, the current page that we're on, a query string, the URL, the first page number, whether or not the query is empty, the total number of records that we have, whether or not it has a total, the last page that we have available to us. So in this case, since we have 50 records, we're doing 10 per page. We have 5 total pages available to us. Whether or not we have more pages available based off of the current index that we are on. And then again, whether or not it has pages at all. And then lastly, we can also provide a raw SQL query using the raw method. So again, this is available via just our database module. So instead of providing a table, since we're doing a raw SQL statement, we can call this directly off of the database module. And then just like before with our where raw statement, we use question marks here to note positions for our particular values. And then we provide those values as the second argument to our raw statement here to protect against SQL injection. Okay, so this really only cracks the surface of the query builder. We've covered some instances where you could do some deeper dives for your data, but you could chain these off as far as you need to go to be as specific and granular as you want to be. For the sake of brevity here, we only touched on each implementation covered here today. If you would like more in-depth options or would like to review all of the options that you have available to you, you can check out the Adonis and Connect.js documentations for those. So in the next lesson here, we've covered the query builder pretty much in depth, ignoring everything relational based. We're going to cover that in the next lesson. So we're going to cover how to query our relationships, aggregate relationships together, and determine whether or not a relationship even exists.